Last lesson, we talked about some of the basic ideas behind sampling. We talked about the different terminologies that are involved in sampling, things such as bias, things such as methods to sample. Today, we're just going to go a little bit more in depth into this chapter 11. Again, this is a wonderful opportunity for you guys to have your flipbooks out, to be filling them in as we go along. When we talk about simple random samples, they're oftentimes referred to as an SRS. What do they do? Well, first off, the whole purpose of using a simple random sample is because to go with the entire population is usually too cost prohibitive, or it's too difficult to try to get everybody to participate. So once we have something that no longer covers the entire population, we have a sample. And our biggest goal is to have that sample be representative. What that means is that the average from the sample is the same as the average of the population. Standard deviation of the sample is similar to the standard deviation of the population. We want all the statistics that we compute to reflect what the total population would look like. That is what it means to be representative. So in order to be representative, in order to fall under this idea of a simple random sample, we're going back to that definition. A simple random sample is where every possible sample, and a lot of times we'll say of size n, any sample of the same size has an equal chance to be selected. This is not the individuals, okay? The individuals are different. That's just the idea of randomness in all. But what this does is this gives every individual an opportunity of being selected. It's not like it's a systematic method where you are only counted if you fall in a certain place in the alphabet or in a book or on a list. This method is talking about the combination of people that are selected. Every selection of people has a chance of being selected. And that is our SRS, simple random sample. So whenever we talk about an SRS, it's very important that you keep that idea of every possible sample of size n, not every individual, every sample. Now an SRS is kind of like the gold standard by which everything else is compared. Now, simple random sample is considered so beautiful because it is by its nature 100% random. And when something is 100% random, it's much more difficult to introduce bias. But there are things that we can do that can sometimes improve upon just straight randomness, because remember, a simple random sample means any sample of the same size has equal likelihood of being selected. If I'm going to select a set of students, maybe let's say 30 students from our population, to go and represent our school at some conference, it's possible that all I get are the last 30 students in any class. So the lowest achieving students, the students with the most difficulty. That's a possible sample. It's not a representative sample, but it is a simple random sample. So sometimes what we'll do is we'll do something to try to force our sample to be more representative. One of the things that we do when we're doing anything that's random, and we mentioned this in the last time, is we have something called a sampling frame. A sampling frame is a list. I think about it as a picture. What goes inside of a frame? A picture goes inside of a frame. And that is a list of all of the individuals, every single individual that can be included, and that's from where we draw our sample. We might do different methods to grab that data, but that's where it comes from. Once you have a sampling frame, this is where we go through and we assign each individual or each element of the sample with a number. And each number refers now to an individual. When we use our random number generators, this is one of those instances where, because we are selecting individuals, you cannot select the same individual more than once. No matter what, when you draw a sample, and we've seen this in class, samples differ from one another. That's called simple sampling variability, random sampling variability. When you go through and you randomly select things, it's just natural to occur that you're going to have different values or different people selected. That also means that the means, the standard deviations, any statistic that we gather from our samples can change from one sample to the next. But remember, our goal is a sample to be as representative as possible so that the statistics of my sample match the population. One of the methods that we do to try to help ensure that our sample is representative of the entire population is doing a stratified sample. This takes the idea of simple random sampling and just raises it to another level. Okay, it's not 100% random. Randomness is still involved, but what stratified sampling does, it's a slightly more complicated design, but in the end, you really do hope that it's going to save you time and money. It's going to avoid some problems that might occur just based off of random sampling variability. Okay, so that's the goal of stratified sampling, to somehow help ensure that certain conditions are met. Now, no matter what, any type of sampling design that we have has to have some element of chance. It's not just human choice. Human choice is going to result in undercoverage. It's going to represent in either voluntary or response bias. Remember, depending upon how a survey is coming to you, that's a problem. So you have to have some element of choice. What this does is it takes a large population and it breaks it down into subgroups. It's a little bit more complicated, but what it does is it makes sure that when our population is separated into homogeneous groups, homogeneous means there's not really mixing. Think about it like your English class. You have English 9, 10, 11, 12. There might be a little bit of mixing in there, but it's very rare that you will have mixing into that class. It's a homogeneous group. Those groups are called strata. Strata is a scientific term for a layer. Just like we have strata in the atmosphere, we have strata in statistics. And in stratified sampling, you break down the entire population into its homogeneous strata. Then what you do is you're going to select from each stratum before we combine our results. So you look at your entire population, you break it down into the layers or the groups that are each self-contained, and then what we typically do is we try to select from those groups in a way that's going to be proportional to how that group is represented in the total. This is called a stratified random sample. So we have that idea of stratification, but included in it is still random sampling within each strata. This is not, by the way, multi-stage sampling. This is just one stage. You are stratifying, and then within the strata you are taking a random sample. Okay? This is not multi-stage. Stratified sampling, if you look at the cake on the right, this is really what I think about whenever I talk about stratified sampling. You want to take a slice of the cake so that it goes all the way through all of the layers. You get some of the vanilla, you get some of whatever purple tastes like, you get some of the awesome little crumbs up on top, the sprinkles. You get every piece in a representative portion to the whole. And that is really the most important benefit of stratifying, is it's going to slightly reduce the variability of our results. If you have a little brother or little sister who gets kind of crazy around cake, you might have noticed that they will just come and they will take a chunk out. And that means all they're getting is this stuff right here. They're not getting this awesome stuff down here or what's over here. They're only getting that little piece. Now that means that's going to be completely different than your cousin who just scrapes the bottom of the pan all the time and gets that very bottom layer that's nice and moist and tasty. Those are completely different groups. By stratifying, by insisting that we get a slice of everything, you're going to reduce that variability. Okay? In reducing variability, it's also going to reduce bias, because again, you're ensuring that this group is represented, that group is represented. Each group is represented in your sample. It can also help us notice differences between the groups, because we might say, oh, okay, let's say this is the group of seniors. The seniors have more problems with attendance versus the freshmen who have more attendance, who have more problems with behavior. So you might be able to see a distinction arise between those once they are broken down into the groups. So that's our cake, stratified sampling. We have randomness within each layer. Each layer is randomly chosen from, but you get something from every single layer. Well, what's up? Next comes cluster. And I mentioned last time that to me, cluster is always like a cluster of grapes. That's because stratifying isn't always an option that works for us. Sometimes there aren't any clear distinctions between our groups. Our groups are nicely mixed. And so what it might be nicer to do is, instead of taking a little bit from every group, if the groups themselves are representative, they're clusters of the entire population, then what we can do is you can just select one or even a few clusters at random, and that is, again, there's my keyword, at random, and perform a census within each of them. What that means is we make 1 or 2 or 3 groups, and we get everybody in that group. Sometimes we'll do this if, for example, if homerooms are broken down alphabetically. Those should be homogeneous groups. It's not always true because last names tend to follow patterns, but it is a possibility. And that's cluster sampling. As long as your clusters or your groups are representative of the whole, cluster sampling can give you unbiased samples. Now, if your cluster is not representative, if I wanted to interview parents of students for Battlefield High School, but I only went to Dominion Valley, that's going to leave out a large proportion of parents, a large representation that has a different makeup. So that's not a good choice there. Now, if I were to kind of pick one street out of each neighborhood, maybe that's a better idea. That's stratified. And that's because, again, within each group, there's homogeny. When they're nice and mixed together, it's like whenever you have 1% or 2% milk, they add a mixing agent in there to get everything to blend. So we've talked about stratified and cluster sampling in addition to our simple random sampling. But where does multi-stage sampling come into play? Multi-stage sampling is when you're using a variety of methods, and no, I don't mean combining simple random sample with just one other thing, but you're combining different things that are clearly different all at once. These are multi-stage samples. Okay, so sometimes when you have a polling operation, what they're going to do is they're going to do a combination of stratified and cluster sampling. Simplified random sampling is built into whatever the lowest level is. For example, we might say I want to figure out the interests of certain income families, and I recognize that these families have different incomes that are represented by different neighborhoods. So I will stratify by income level, and then I will try to find a cluster within one of those samples that's indicative of that whole group. And then inside that cluster, we might come back through and do simplified random sampling. Okay, so a multi-stage sampling is a combination of more than one of the following. Talking about a systematic sample, stratified sample, or a cluster sample. That is where we have multi-stage samples. Systematic samples is when you, well, surprise, surprise, have a system that you're going to follow when you're creating your sample. It's not 100% random, but sometimes it's just very, very easy to do. So you might take every 10th person. To make it random, okay, this is where the randomness comes into play. You've got to start the systematic selection from a randomly selected individual. Otherwise, if you always take the first name on the 10th page from a phone book, yes, there used to be these things that had all of these numbers in them. We called them phone books. They were great sampling frames. But if you always start from the same spot, then it's always the same individuals that will be selected. So we have to have some random start for this. Now, sometimes you can believe that when you're following a system, it should be representative of the entire group. For example, if you are surveying people that come into a grocery store, maybe choosing the 5th person that comes through to talk to is easy. It'll give you time to talk to them, and then it'll keep you in a pattern so that you're not pointing out or picking out specific types of people. So it can be a good thing, but you can't automatically assume that a systematic sample is going to work. For example, certain parts of the alphabet tend to go along with certain racial backgrounds. You think about all the people that have the last name Smith, all the people that have the last name Lee, all the people that have any other common, Nguyen. Nguyen is a very common last name as well. And when you're looking at that group, you might have a skip over if you're not careful for that entire ethnic group. Now, it's a lot cheaper sometimes than true random sampling because it's predictable and you know how long you're going to be someplace, you know the number of folks that you're going to interview or that you're going to collect your data from, and that can make the process go a lot simpler. But remember, our goal is always to have a representative sample. So sometimes whenever we do these samples, we put a little caveat in our statement when we're talking about what type of a sample we're going to take. We always say we hope it is a representative sample. Now, when you do use a systematic approach, you have to make sure that you justify the choice that you made and be able to explain that whatever you're trying to measure, it's not affected by the system in which you chose your subjects. For example, if I'm starting my interview process at Starbucks and I come in at 9 a.m. and I stay until 9 p.m., well, that's going to lose a whole branch of the early birds that get there super, super early and maybe have extremely strong caffeinated beverages. So you want to be careful that your sample method does not actually affect your outcome. You don't want it to bias. Very important to do here is to always define the who, not the band, the W's. So remember, just like we did in the very, very beginning, the who of the survey is the group from which you are gathering the data, not who is doing the gathering. So it's very important that you identify your who so you don't have this confusion about what your study is about. Not being clear enough about your W's is a huge problem in studies today. Always start to think about what is the group that I'm interested in learning about. It's not always going to be something well defined. You might not have a straightforward, simple answer, yes, this person is in that group, but that person is not. So you want to be very careful. If your population is clear, the group itself that's within that population might not be a good group to go with. And you always must identify your sampling frame. The sampling frame, that place from which all of my population comes from, is not always the folks that I'm really interested in. I might pull a list of students from Battlefield High School and have a sampling frame of all of the students. But if I'm only interested in seniors, I don't want to see all of the students. So that sampling frame is not what I want to use. I only want to use a portion of it. So you always want to make sure that your sampling frame is focused on your population of interest so that it is going to limit what you can learn from your survey or your experiment. Okay, more with that, you have your target sample. And these are, you've identified your population, you know who you're looking to interview, you're looking to gather information from. But then you have to talk about who you're going to get your results from, because it's not always going to be that every single person that you ask to participate does participate. You might have non-response where you supply the survey, but the answers do not, for some reason, come back to you. Either you couldn't get a hold of them or they didn't have the means of communication that you expected. Or maybe you have voluntary response bias, where only the people that feel very strongly about something will reach out and participate. So just because you've identified your group of interest doesn't mean they're all going to respond. And then once you do have your sample and you do have those people who are participating, then you get to draw conclusions. But only if your sample is representative. If your sample is not representative of the entire population, remember that means that the measurements that I grab from it will not reflect the measurements of the true population. And sometimes you just have to really examine those that were selected to be in your sample and say, hey, does this work or doesn't it? Okay, I know this has been a lot. One of the hardest aspects about statistics is the level of context that's involved. It's why everybody hates word problems so much. You have to really think and really pull apart the information that you're given. But that's also what makes it so interesting, is that every single thing that we do in this class is applicable to a real world situation, or many, many, many real world situations. Now, why do we do a random sample if some of the others can kind of force my sample to be representative of the total population? Well, that's because no matter what steps you take to try to be perfect with this, it doesn't always work out. And a simple random sample just truly takes it completely out of your hands and makes it as random as humanly possible. So your selection is purely up to fate. How did that number generator work out? How did you flip a coin and get these people to be included? And that's not necessarily true when you're following some sort of a process, simply because maybe you assign your groups wrong. Maybe in your groups you always are selecting the same type of person. That's not representative. So you've got to be very, very careful with how you do your sampling. So we've talked about being random and the importance of that. We've talked about how we can apply random to select samples in addition to mimicking a simulation. But we've also talked about things that you can do when random is not exactly appropriate. Things such as stratifying or clustering or doing a systematic sample. They all have their benefits, they all have their strengths, but they all have to incorporate some form of randomness. All right, I hope you got what you needed from this, and we will continue to go over this in class. Thank you very much.